Everybody, I just attached the link to the notes page, the collaborative community notes page off in the chat. So if people wanted to go put in your name or your organization and country in there, feel free to do that. And Casey, can I just get an audio check, make sure I'm audible and make sure you are? It should be presenting today.
Yes, I can hear you. Can you hear me?
I can, and it's wonderful to hear you.
Great.
All right, we'll give people a chance to kind of migrate from their other calls. Give it a few minutes.
All right.
Hello, hi everyone. Can you hear
Paul?
me?
Yes, we can hear you as well.
Okay, thank you.
All right, Paul, we can see your screen.
Okay.
Casey, maybe we'll just give it a couple more minutes and then maybe we can get started. Does that sound good?
Yep, that sounds
Good.
great.
Awesome.
So we'll start in 2 minutes at 5 after, just making sure folks have a chance to join. Well, I think maybe we should just go ahead and get started, and folks can join as they continue to trickle in. Let me turn on my video to say hi to all of you. Good morning, afternoon, and evening to all of you all around the world. My name is Casey Amshauser. I wear a few different hats. One is a senior digital health specialist with the Digital Initiatives Group at the University of Washington. And as part of that, I work on the Open Ellis lab information system. I'm the owner of product there, so I help prioritize things, work on the general roadmap, and I'm also a co-lead of the OpenHIE LIS community practice. And I'm joined here today by my colleague of, 14 years or so, Paul and Ria Soa. Paul, do you want to go ahead and introduce yourself?
Okay, hi everyone. My name is Paul-Henri Assoin. I'm HI specialist. I work in the SI branch chief at ITECH Cote d'Ivoire. ITECH Cote d'Ivoire, we are leading some HIS activities and development in Cote d'Ivoire funded by the CDC PEPFAR.
All right, great.
Okay.
Yeah, go ahead, Paul. Take it away.
Okay, thank you. So this morning or afternoon, we will have to share our experience of in building Cote d'Ivoire HIE with some standard connection that we made between our EMR based on OpenMRS with OpenLIS for interoperability. So in Cote d'Ivoire, the health informatic information system is very play a critical role for improving the quality of healthcare. Also for help the ministry and the other side to support data-driven decision-making and ensure efficient management of resources. So despite the progress and many efforts made by CDC PEPFAR, we still have significant challenges that about that fragmented data system that we have because we have many systems in the country. We also have a limited interoperability between the system, and we still to fight to reduce the delay in assessing vital patient information. So to address this issue, ITECH funded by CDC PEPFAR, CDC PEPFAR in Cote d'Ivoire, has been implementing some innovative solutions focusing on firstly in laboratory, but since 220 on patient data also manage information. And the big project that we have for create this interoperability between this key platform. So we started in 2009 by implementing the OpenLIS, that is a laboratory information system that we have. And we still to make some different features and civil developments. So the goal was to deploy this standard laboratory information across multiple sites to streamline data management. Also ensure consistent and accurate laboratory data collection and for the reporting, and be able to centralize access to the data for the OpenLIS consolidator to be sure that we can have access to the result. So firstly, for OpenLIS, with our implementation 6.209, now we are installing OpenLIS across all the country in 170 laboratories, including TB laboratory, military laboratories, and 24 viral load platform for perform a test about viral load and HID testing. We also installed OpenLIS in 40 relay lab. We call it here as a hub, and other regional lab asking by the Ministry of Health. So the way is to connect all the platform to the internet to support real-time data update. So integrate also the TB specific functionality that we have, including tailor form for request. We also started working on microbiology, including microbiology information of the system, and ensure maintenance and user support. And be sure that we can carry a training at different level by the MOH and IT lab staff. We organized some training with the MOH, and now the MOH since 10 years now are able to make all the training with site support across the country. So the big challenges that we have for this implementation of this the laboratory information system This resistance that we have in the site to adopting new system among the laboratory personnel. Also, the limiting internet connectivity in this rural and remote area. So for the perspective of the next step, that is to expand infrastructure to improve connectivity in the region and provide ongoing training and the support to enhance system adopting and usage. After this open LI system, we also have to develop the LI's data management in viral load. We call it here viral load dashboard. So the objective was to develop a robust dashboard for monitoring viral load suppression nationally and leverage laboratory data to guide intervention and reduce HIV transmission. So the activity that we have to make that is to collect and aggregate viral load data monthly and design implementing and user-friendly dashboard and data visualization and conduct training session to promote this dashboard that will be used for the ministry and the different districts. So we are each month able to present at a national level this dashboard. We present all the activity that we have made and we set about viral load at DID. And that's helped to improve quick access to the lab aggregate data, to improve access also for real-time for viral load tests and for the monitoring. We be able to develop this dashboard using by a strong collaboration also that we have and sharing experience with the Kenya team because we developed this platform in 2016. And the trip that we make there at Kenya was very benefit for us. And we continue all time to greet the Kenya time and teams for the availability and also for the support by sharing experience with us for develop this dashboard that we have. We also, for this dashboard, this challenge is that for the limited utilization of this dashboard by the stakeholder, because only the ministry guy use it, but the IPs has over internal system that we have for manage the all the data that we have. They don't use it, but this dashboard is a national level. The information that we display on this dashboard is what is this data that they use at the national level for all the presentation that they have. And we need for continuous stakeholder to training to maximize tool potential. The perspective that we have that to be sure that we can improve this usability of this dashboard and a conduct target campaign to raise the rate of the promote adoption, build the dashboard on the consolidated server, because now we developed a consolidated server. And the ways will be to connect directly this consolidated server to the dashboard to be sure that we can have information also in real time. And since 2020, we work with the government to improve the development of SIGDEP3. So our SIGDEP3, that's the EMR based on OpenMRS. OpenMRS has the old version with 2.6. So we developed some new features, and actually we are working to be sure that we can finalize the development of a consolidated server for the EMR. So actually we have made some tests, and this kind of dashboard, that is the first pilot that we have with the test that we have by collecting some information that we have in some tests, but we're still working on that. But at the end of this CUP, we think that we'll be able to finalize this consolidated server and have all the different sets because this EMR has been deployed in 500 sites in the country. So that will be good for us to have a kind of consolidated server to aggregate all the information from the EMR and be able to present this kind of dashboard for them. And we also, since last year, finalized the development of a consolidated server for OpenLIs. So the goal is that is to aggregate data from all OpenLIs that we have, instances that we have in the country. But actually, that is more specific for the 24 PL platform that we have that will be connected directly at internet. And the activity that is to develop and deploy the open consolidated server and have this automatic synchronization of the data So directly, all the information that has been recorded on the site is automatically available on this consolidated server. And also that gives us this chance to be sure that we can have also all the results at real time in the site. So we were able to present a kind of platform that can be used for the user on the site. So as we have aggregate information from the site, we are able to make a patient follow-up directly on the consolidated server about viral loads result that they have. So you can see patient history. You can see how about the viral load test that we have as kind of a result. You can also monitor all information about a record that they have made directly on the laboratory to see the status of this order that they made. So that helps us to reduce the turnaround time for this result that we have, and improve the access to the patient for the data and laboratory performance metrics, and support also decision making. So the challenges that we have actually, that is the quality of internet connection that we have in the country that is not so famous, but also data synchronization, ensure that all the platform must to have internet connection and synchronize without loss of all information, and optimize the use of this data for the consolidated server. We already deploy this solution at the country and create the user. So now all the sites are be able actually to monitor the order using for the test that we have made in the consolidated server. And the whole action that we have, that is the interoperability between OpenAlyze and SIGDEP. SIGDEP means for us the EMR that we have developing based on OpenMRS. So we developed some module in SIGDEP to be sure that we can be enabled to make some electronic order and deploy the interoperability using Appifier and OpenHIM. And we conducted a pilot last year, pilot test across 19 platforms and 45 clinic sites. So we were able to streamline data flow between laboratory and reduce delay and error in the data exchange. As now that is some electronic order, so the most information has been taken directly on the EMR, so that reduce all the data that we have to record in the laboratory, and so that reduce the error. And also improve the patient careful timeline access to the lab result, because when the result is available directly on the laboratory, the results at the same time come back on the EMR. So the first pilot that we made on this 45 site, we were able to see that is a kind of summary that we did. So more than 2,000 requests is created by from SIGDEP3, that is electronic order. And but that they use internet connection, and the connection with our central for OpenHIM for as a layer for interoperability. And we more than 2,000 requests updated to OpenAlyze. We also receive more than 1,900 requests, electronic order requests in the different OpenAlyze from on the platform. Also, the requests are processed in OpenAlyze, and 700, more than 800 results come by return at the SIGDEP3. We have to understand that the result return on SIGDEP3 when the test has been completed. That's made at a validation, at biological validation. So for all the different intermediary steps that we have at the laboratory, that means record the information, put some results, waiting for technical validation. All this information has come back on the status of the request in the SIGDEP. So SIGDEP, the guys that monitor SIGDEP know exactly the real status of this record, this electronic order, on the laboratory. And one, we can say final result means that is a biological validation. So the result is able to return on the SIGDEP free. So that is the form that we developed in the SIGDEP for the electronic order. So actually in the country, we use a paper form. So we develop it directly electronic paper form with all the different items that we have. And at the left, we are able to see the over electronic order that we have made on the laboratory and the status. That is on SIGDEP free. And here that is the interface that we have, the user interface that we have in OpenAlyze, where we receive automatically all this electronic order. So we are able to edit or to reject or maybe to cancel. And this information returned for the status of this sample at the laboratory returned directly as information on the SIGDEP. If that will be accepted on the laboratory information returned on the SIGDEP, we say that that's accepted, so you have to wait for the other step. If that will be rejected, they can be able or cancel. It can be able maybe to restart the electronic order to bring a new sample. So the outcome of this interoperability between these two systems that is to reduce the delay and the error data exchange, because we have the same information in these two systems about the viral load test, and improve the patient care also. So the challenges that we have, that is the internet connection quality, that we continue to have it and to synchronize information. And this interoperability approach has been based on the FIRE. So on this based on FIRE. So for this important phase, you have to firstly understand more what's the different step of interoperability layer. So the first step that is the syntax using the FIRE. So how this data be organized. So from the lab order that we produce from the EMR for the resource and the different service that we have. And that is a kind of a message that we send using the interoperability layer OpenHIM. So we have to understand more how that will be organized, and we are learn about that. And the other aspect that is semantic about how we have to exchange information between these two systems. You have to be on the same way, on the same page. We want to talk about some different aspects. So for example, want to talk about a facility, it's important that we share the same name of a facility to be sure that we talk about the same site. Want to talk about the tests that will be ordered, it's important to be sure that is the exact and the same test that we're talking about that. So, and so that is the two aspects that we have defined and more learn and understand on this FIRE way that we have used. The architecture that we proposed to the ministry and that will be accepted for this interoperability was this architecture. So we can see, as you can see, the SIGDEP that we have at the different level, and that we actually had to develop a consolidated server. And also in the bottom here, the different OpenAlyze that we have from the different sites. So to be sure that we talk about the same patient, we developed a client registry, a system that is OpenSIA. That's be connected directly for the SIGDEP to be sure that we can make some deduplication of a patient, but also have the same patient codes that are on all the different systems. And the OpenAlyze consolidated server that we propose, that is this architecture, because the final goal of the ministry here is to produce a national data repository. So for the first point that we have actually, we want just to develop this national lab data repository. And using the OpenHIM for the layer, we are able using FIRE, because the standard that we are using for data exchange is FIRE. So using FIRE to be sure that we can share information between the system that we have. So for the next part about the interoperability and the different level, I will let my colleague from Casey from DIGI to explain more the different aspects that we have developed and that we have learned using the Fire object that we have developed from EMR and also the Fire object that we have developed in OpenLIS.
Great, thanks, Paul. I think I'm going to take over the share as well. Or
maybe I can continue
yeah.
to share and yeah.
All right, and we'll leave it on yours. Okay, so talking about the interoperability between the OpenLS lab system and SIGDEP built on OpenMRS, you can see here the sequence diagram. This should look extremely familiar as it is this sort of base OpenHIE lab and EMR workflows. So we wanted to do a number of things. So we wanted to reduce the efficiency of things by making sure that we're not double entering both in the EMR and on the lab system. We needed the data to exchange between the two systems without much intervention by a person. We were trying to make sure that we weren't duplicating requests and making sure that we had one single entered result for each test. And then also being able to pull everything into a that consolidated server that Paul was talking about earlier. So centralizing all of the different lab requests and then facilitating also when a test can't be performed in one particular lab, it can then be transferred through the National Lab Information System to a national reference lab to go ahead and carry out that test with the results flowing back to the original, both the lab that had forwarded that information, forwarded that order, and the original clinical setting where the order was taken. So you'll see the EMR will create a lab order, and we'll talk in a minute about the different Fire objects that happen at each point. So the EMR creates the lab order. We'll talk about this in a minute, but in a local lab, that would be saved on a local Firestore that's part of OpenLS. It creates that lab order. It creates a new task in the local Firestore. The EMR pushes a set of information. So that's a task, a patient resource, a task, a service request, and some other things up to the lab information system. Finally, that task resource gets updated with each of the different steps. So that way the EMR can tell exactly what's happening. Has that order been received in the lab? Is it in progress? Are there preliminary results or final results? And then finally, we return the diagnostic report along with the encounter information back to the EMR. So that gets updated, pushed up to the Firestore, and then the EMR goes and picks it up. Paul, will you go to the next slide, please? All right. So speaking of things at the central or at the local level, we are a little bit lucky in that since we're using everything in Fire, we wanted to have a local Firestore. One of the things that we did on the OpenLS side in terms of architecture was we decided to bundle a happy Firestore with OpenLS. So each OpenLS has its own sort of local Firestore that it uses to hold Fire objects. It also, in this way, can really help with interoperability because locally you've got your SIGDEP 3, which is based, like Paul said, on OpenMRS 2, or SIGDEP 4, which is based on O3. That one's about to be piloted. And they're both using two modules. These are built into O3, but can be added to OpenMRS2, which is the Lab on Fire module, which helps the lab workflows conform to the fire standard, and the Fire 2 module. Anyway, those create the fire objects. Those get sent through the local OpenHIM and over to the internal Happy Fire store for OpenLS. That's where all those fire objects are locally stored and then pulled into the OpenLS web app, where the lab, where the actual work gets done on the lab sample, and then everything is sent back through that local HIM and back to the EMR. So one of the great things about this is that it works either online or offline. And then as soon as that facility goes online, it can start to push things up to the national central level. And of course, if things are online to begin with, they get stored in the Happy Store, then immediately pushed up. And that has some added benefits. As Paul was saying, there are some other systems connected on the central level, but we'll talk about that at the next slide. The EMR, when it creates everything, makes that task, patient, service requests, objects, and encounter objects. And then, like Paul said, doing the matching of the tests and the panels on the order is using LOINC. And this can be streamlined using concepts we're working on as part of the Google Summer of Code. One of our proposals is to be able to pull in concepts from the same concept dictionary that you're using for your medical record system, and then you can build out a test catalog with the same LOINC identifiers between your two different systems by using the same source data. All right, yeah, we can go to the next slide. Speaking of the different fire objects and sort of how you can tell, well, what fire objects are in play, how are they formatted, how would I actually go about using this in real life, and what are some of the example objects that we're using. There are fire implementation guides for both OpenMRS and OpenLS. And if you're not familiar, an implementation guide lists out all of the different fire objects that are used, talks about what we use each of those identity fields for, whether they are expecting, whether it's a one-to-one mapping, so it's expecting only one particular object in that field, or if there are many, that kind of thing. And it can really help you drill down to all the different layers of your fire objects. One of the great things is that at OpenLS, we developed our fire objects at about the same time as OpenMRS. So when we were trying to figure out, well, how do these mappings look, we made sure that they were compatible and that we were mapping things to the same source. You can still use this if your mappings are a little bit different, but you'll need to keep that in mind when you're parsing your fire objects in your final application. All right, next slide, please, Paul. So now that we've talked about things on the local level, when we talk about things at the national level, everything flows through another OpenHIM layer. So we've been using this at both the facility and the national level. In the Instant HIE v2 is our deployment methodology. So we're using a Nginx sort of wrapper to reroute all of our network traffic back to different subdomains that then are locally routed to different ports. So that's kind of nice in that we don't have to have a whole bunch of ports open for things. Both OpenLS and OpenMRS have the ability to stream data over Fire. So that's one of the things that Lab on Fire module does, is create the fire objects, and then the Fire 2 module helps to stream that up. So hundreds of millions of transactions have been flowing in production through OpenHIM, and then they flow up into a national data repository which for Cote d'Ivoire at the moment is a very large Happy Fire fire store. It can hold both the lab data and the EMR data. Connected to that, we have a number of different tools. So Paul had showed off a little bit the viral load platform that has some of the information. And we've got the pediatric case management system that takes some of that EMR data and some of the lab data, combines it for following up on pediatric cases, and then like things like lab sample tracking systems. We go from that point, we like to use the what we call the fire pipes. We use the Google Open Health Stack to connect to our fire store. And what that does is it takes the fire database, which is really, really great for transactional level exchanges. It does a super good job of that. But when it comes time to run some of your reports and dashboards, it's important to flatten out your data structure so that you can build faster views and make sure that things are more performant. So using the Open Health Stack, we flatten out some of our tables to do the reporting and dashboarding. I do see a question on OpenHIM. Do we have two instances, or do we use the same instance at multiple levels? We use two different instances of OpenHIM. So there's one running locally on the local server that's running SIGDEP and OpenELIS, and then a second one that's running at the national level. And because we're using all fire, what we're mostly using OpenHIM for is to do the routing, authentication, and logging, because it does such a good job of building out things like audit trails. We find it to be super, super useful in that way. And then we set our routes, set up the clients, and set up all the authentication between the different pieces in the system. And other than that, yeah, it's just a fire pass through. So finally, you know, what Paul was talking about, one of the things I should have added to the national level tools is that OpenCR, so you can start to do some deduplication on the clients between the two different systems, as well as, of course, you're able to share the same patient objects between your EMR and your LIS, which is extremely handy. So both OpenELIS and OpenMRS version 2 and 3 can connect to that client registry directly, and both submit new patients up to that centralized Firestore and download demographic information. We've built out those dashboards that Paul was showing you. You can use some different objects. You can do both Superset or Power BI or whatever other kind of visualization software that you're used to after flattening everything out. We have quite a bit more information if you want to look at some developer guides or go in depth a little bit more on the tech stack or how these different fire objects work. You can check out, there's healthinformationexchange.org, which is a interoperability knowledge base that's run by the UW DIGI team that you can link to also off of our website. All right, well, that was our last slide, other than the thank you slide and another link to the website, but we wanted to leave the last 15 or 20 minutes to get some questions about any of this. If you want to, you can just come off mute. No need to type.
Casey, it looks like somebody has their hand raised.
Yeah, I have my hands up. So thank you very much for the wonderful presentation. I think if you can take us back to a slide where you have the architectural diagram or flow diagram. That would be nice. I have my question. I think it's in line with what Jennifer. No. Go down the next. Go to next. Next slide. Next. Yeah, maybe you can go to the next because that's it's more clear there. Yeah, so this one. So I think this is a good one. I'm just discussing with my colleague sitting here, and we feel you. First of all, you have a good mapping of your terminologies, which gives you, easy way of exchanging data between the OpenMRS and OpenELIS. And then the question, like Jennifer asked, that is not clear from this diagram is the OpenHIM. So do you have different or separate mediators at the facility level and at the national level, or it's a same mediator that speaks to that enable handshake between the two systems? And okay, so the other one is I wanted to know OpenELIS is just remind me, is it open, like open that people can access and adapt? And what was it based on? And how is the development and update made if it is open? Is there according to practice or something like that? Thank you and all.
Great, thanks. Those are great questions. I'm going to start out with what is OpenELIS. I should have covered that a little more. So OpenELIS is an open source lab information system. Much like all these other open projects, it's completely open source. It is supported by a very active community. I really love our community. And the product is stewarded by the University of Washington. So that's where I'm at. I've been working on it for about 13 or 14 years now. Yeah, so it's definitely out there. Our website is openelis-global.org, and you can find links to our documentation. You can download the application itself and try it out, or you can try our online demo. So there's quite a bit out there. We definitely recommend come check us out. We have connections also. We can connect to things like clinical lab analyzers. We've just been working on finalizing the plugins for bidirectional communication with things like the Gene Expert. So you can run all of your cartridges and pull all of your results directly into the LIS. So no data entry there, and do things like you can scan the lab samples and pull that data in through the LIS. So that's pretty great. And it's also built out such that it works great in one individual lab, but you can also build out a full lab network and start to share things like your data across each level of your lab system. So it's a very, very quick one on OpenELIS. And then in terms of this interoperability, we have two different OpenHIMs. Because if you want to think about it, we almost have two different HIEs, or many, many different HIEs. One is within the facility that may be online or offline, so we can't necessarily count on being able to reach the central fire server to pull down information, perhaps because the internet connection is not good or there's some issue with it anyway. there. So at the facility level, we have an OpenHIM that's running that everything then from the OpenMRS instances actually gets passed up to the OpenHIM layer and then routed back down to OpenLS's Happy Firestore. And then from there, that Happy Firestore really communicates up through OpenHIM and then back down to the OpenLS web app, as well as there's a direct API between the two. But all of these transactional um, bits happen through the OpenHIM interface. So this is at the facility level. And one of the great things about this is that you can make sure that you're routing everything such that you can get from your EMR into this local Happy Firestore. Once everything's here at this local Happy Firestore, we also have another OpenHIM connection. We're not using mediators because it's all fire to fire. So we use it for the authentication, the routing, and the logging. And so once this Firestore connects to this central Firestore, then we start streaming the objects from this local Firestore up to the national one. And we use that that streaming. We are using something that we've built right now, but we've been working with the team at the Google Open Health Stack to try to build out the ability to use that set of tooling to do syncing between the two different Firestores. So as you can see, if every facility has a Firestore, and we have, I think Paul showed 203 different OpenLS labs, that's 203 different Firestores that are all streaming up to the central one. So I hope I answered your question. And then next, Mubarak, please.
All right, thank you very much for the great presentation. Although unfortunately I joined a bit late. So I have some questions with regards to this. First, you said it can be used in a lab network. Does it mean that when you have the source code, you can implement it in the way that it will be a kind of multi-tenant application that's creating for different labs, because we have different lab networks instead of having different instances of it? That will be my first question. Then my second question has to do with the Gene Expert. You pointed out that it can connect to the Gene Expert. So is it that for the Gene Expert, we don't need to be buying nodes for the different Gene Expert sites, because the current configuration we have is that you have your Gene Experts, then you now need to buy nodes for it to connect to the platform. So is it that there's a direct API to the Gene Expert machine and we don't need to buy nodes to it? That's my second question. Apologies, I'll go to the third question. So from this slide we have here, I can see that it connects to different dashboards, and I can see you can have connection to Apache Superset. So this, I guess, is going to be like connecting to the database of the OpenELIS itself, right? So that we can create different indicators and do some of our data analysis on the superset. Thank you. Those are my questions for now. Over.
Yeah, thank you. So one of the cool things is OpenLS is built with Fire is sort of baked into it. So when you're doing things in the OpenLS app, like let's say registering a new sample, registering a patient, or entering a result, all of that gets created in Fire anyway within the OpenLS app. So once all of that's created in the OpenLS app, it goes through the mediator up here to the Firestore. And then at that central level, we take that transactional data. We use the Open Health Stack to flatten all of that out and then connect the superset or Power BI or whatever visualization tool you want directly to the flattened out Spark dashboard, Spark database that's part of that Open Health Stack. So it is the data from the OpenLS instance, but it's yeah, it's been flattened out just to make it more performant. To talk about your the other part of the question for multi-tenancy, oops. So multi-tenancy kind of exists. The way that we look at it is we don't create one lab instance that is meant to be sort of running all the different labs, but it's containerized within Docker. So what you can do is if you have a central system, you can spin up a number of different labs and use the built-in load balancing to make sure that everything's performant. And it's built in a hub and spoke kind of model where for sites that don't have fantastic internet, you can install it on the local network and then have everything sync up to the central level. So you really don't need live internet at all. When it comes to, and please come off mute if I didn't answer or if you have follow-up questions.
No, I really appreciate you answered my questions, and I'm satisfied with that of the gene experts.
Okay.
Very satisfied. Thank you.
And then, yeah, for the gene experts, they do directly communicate with OpenELIS. So when you have the OpenELIS instance that is in your lab, you connect each gene expert directly to OpenELIS using what's called the ASTM protocol. And the ASTM is a huge standards organization. It's like saying the ISO protocol, but there's a particular protocol that's built into most of these clinical analyzers, and it can swap information using that protocol. So, yep, it directly connects to all the different gene expert machines. It brings those into the lab software, so it kind of fits into the normal lab workflow. You just import your result rather than recording it from a dropdown or typing in the result. Goes through the same validation, and then everything streams back up to that central level and out to the EMRs if you need it. And let me get to the from Bright, the terminology question. Do we have a dedicated terminology service that the OpenELIS and EMR use to code the lab test? I'm asking because it's possible that the EMR has its own terminology server, OCL, that is already mapped to LINQ coding. It's a really great question. And we are working on being able to connect OpenELIS to that same OCL collection to build out the test catalog and to import things like the LINQ mappings. Currently, before that's done, it actually gets pretty simple. It is manual, but it's not crazy. And that if you take your concept, so let's say the concept for red blood cell count was 1, 2, 3, 4 in the SEAL concept dictionary, and you're using that concept to do your test ordering within OpenELIS. And I could show this, but it's really not very fascinating to look at. Within OpenELIS, when you define your tests, we simply have a box that says LINQ code. In the future, if you connect it to the concept, you should be able to pull that LINQ code from that concept. But right now, you'd have to copy and paste it. Once you've copied and pasted, then as far as it's concerned, the lab system will connect it to the concept for the test you're trying to order. That also works for panels. Yeah, so you might need to change on the lab side, the LINQ coding. One of the interesting things about LINQ is that it gets ridiculously specific. So it's not just which test are you ordering and running, but it's which method are you using to run the test. So let's say the LINQ code for a Gene Expert DX might be different than, this is a fake machine that doesn't exist, but the Gene Expert 2. They might be running exactly the same test, but say a hepatitis B surface antigen, but use two different, completely different LINQ codes. And so in that case, and big shout out to Andy Cantor for helping me understand this, is that oftentimes you're going to want the LINQ code for kind of the umbrella concept. So a more basic version of, okay, well, then just give me the concept for the the hepatitis B surface antigen in general doesn't matter which method, and you might use that for doing your total counts before diving even deeper to know, well, how were each of these tests done? So I always like to say it doesn't have to be technically the most specific, as long as they match between the two systems and you understand what it is that you mean by that, then that should work. And then a question from Chris that says, looks like this architecture assumes that the labs are located at the facility level. Am I correct? Somewhat, yes, at least conceptually, right? So the way that folks have actually deployed OpenMRS and OpenLS is you do have one container. So let's say one database that represents a particular lab or a particular location. And so that can be at a central level. So you could have a big national data center that is serving out many different sites, EMR systems and lab systems that for the sites that have really good internet connectivity, so you don't have to worry about that. And then other sites that might be offline and actually running at the facility. So it's either way, but conceptually, you're going to have a separate database, separate FHIR objects that say they're coming from this particular system to help identify everything. Chris, let me know if I answered your question, or if you have more, please go ahead and yeah, ask in the chat.
Casey.
Yes, Paul.
Hello. Yeah, can I have something about the answer to Mubarak? Just to say that for OpenLS, one of the strengths of OpenLS that is it's a very flexibility. So you can connect multiple of our analyzer. We just need to have data. The analyzer need to have this feature to export the results as for a test to a test format or CSV format, or maybe a format that will be easy to manipulate. So actually in the OpenLS and in our country, we are more than 20 analyzers that have been connected. So it's very easy to develop a happy for the different analyzer that we have. But we just need to have the features to be able, this analyzer to be able to export a result as a test format, or maybe a format that can be easily to manipulate.
All right. Thank you very much.
Thank you.
Well, I think we're coming up on time, but if you have any, oh, we've got one more. Can we directly exchange data between OpenMRS and OpenLS using Isante Plus? I'd like to know a little more about that question. So Isante Plus is the sort of Haiti version of OpenMRS. So it's a customized OpenMRS for Haiti, and definitely it's doing the same thing. So that OpenMRS is similarly creating the FHIR objects and can send them to that OpenLS local instance. So short answer is yes, and exactly the same way that Cote d'Ivoire is organized. And Andy, I believe we did run that, and I thought I sent it in, but let's follow up because I did think I sent in those concepts. Oh, wrong script. Whoops. Okay. Well, we'll do a different script then. How does OpenCR uniquely identify patients if patients are moving from one facility to the other? Does it use some national ID for each patient? Yeah, wow, we could get into a whole thing on patient identity and be here for another hour. But the short answer is that OpenCR has what it considers a golden record ID, which is a UUID created only by OpenCR, that just identifies that golden record, and then it creates out links to all of the other different patient objects that are linked to that golden record. And so one of the things in each of those patient objects that are connected to this golden record UUID is the ability to add any number of different identifiers. So in each patient object, you would have one thing that is perhaps national ID, one that is perhaps a health system ID, one that's maybe even a local hospital visit ID. So if someone gets an ID for each hospital visit, and then those all get sort of created, added to the FHIR object that is then pushed up, and OpenCR links it together. So you could even have, in some cases, two different, say, national IDs because one had a typo in it, but they're still linked to that same UUID for the golden record. Let's see. And then finally, Nigel's question, would BONME provide the same level of interoperability that we've achieved using separate instances of OpenMRS and OpenLS? That is a great question. There are a few different systems like BONME that take everything and combine it together and sort of pre-configure things for you. The closest to what Paul-Henri has shown us would be the ozone system, which takes a sort of out-of-the-box approach with OpenMRS version 3 and OpenLS version 3 as well, and puts them together, uses Aspire for interoperability, exactly like we've explained. The BONME version, it's using a much older version of OpenLS. I think it's using an older version of OpenMRS, and it's using an Atom feed to kind of stream between the two systems, so it's not using that FHIR interoperability layer, although you could certainly update the components. Yeah. So this is kind of like a more modern approach to the interoperability than the Atom feed, but that was developed back before the FHIR endpoints. And so one of the great things about this is the ability to stream all those objects up to the central level and reuse them for things like OpenCR, you know, a whole bunch of other FHIR-based tools, and that Google Open Health Stack as well. That's all kind of built off of FHIR. All right. Well, with that, any other questions, please come out. Come find us at our communities of practice. OpenLS has forums and Slack groups, all kinds of good stuff. So we love to hear from you, and we love all of your questions. So thank you so much, everyone. And big shout out, thank you so much to Paul. As you can tell, he has been working on all of this in real life and has done an amazing job, and is one of the sort of Francophone leaders in health information exchange. Thanks so much, everyone. See you next time.